So welcome students to the new lecture on analysis. So in the previous lecture we have started the topic that is Riemann integration. Today we will do one or two questions based upon the Riemann integration. So I hope so you will do the question side by side, and I will ask the question, I will ask the answer from your side also. Okay. So let's start the question, and I'm sharing screen now. Okay. So question is let f of x equal to x square. Let f of x is equal to x square. Okay. On closed interval 0 comma alpha, on closed interval 0 comma alpha, where alpha is greater than 0. Okay. Show that f belongs to R integrable 0 comma alpha. Okay, and evaluate integration 0 to alpha 0 to alpha f of x dx. Okay, so let's do this question. First of all, yes, what will be our first step? Yes.
Sir, to prove bounded.
To prove it is bounded or not.
Yes, we have to prove it is bounded. Means since x belongs to 0 comma alpha. Okay, so we can say 0 less than equal to x less than equal to alpha. So squaring both sides. Sorry, squaring both sides. So you can see here 0 less than equal to fx less than equal to alpha square. So you can say f of x is bounded. F of x is bounded function. Okay. Now,
सर एक क्वेश्चन था
yes.
सर कब ये बाउंडेड नहीं होगा सर?
Bounded when it is always bounded when you are taking the closed interval, first of all. Okay, because here alpha is greater than 0, alpha is not defined. If we are taking real number, so there it will be bounded. Okay, because we are taking the closed interval, so every time we are getting the function as bounded function. Okay.
Okay sir.
Yes. Sine, we are taking the square, we are taking alpha is greater than 0. So there is nothing matter of the sign here. So if alpha is your, let us suppose 0.3. Okay. Sign will be changed. One question we have already done. That question was 1 less than equal to x and less than equal to 4. It is depends upon the inequality. Okay, and one question we have already done. I could not memorize that question. We have done such
लिमिट से
case.
होनी चाहिए सर, मतलब सब कैसे सर स्क्वायर में वो चेंज होगा सर साइन?
Square, it is according to the according to your whether it is less than or more than. Let us suppose it I have, let's suppose I am taking this one, minus 1 less than x less than equal to 2, maybe here. So it is 1 less than equal to x square less than equal to 4, no change. Okay, one case we have taken. Or Komal, have you remembered that case where
सर
we have
अगर
Yes,
taken
दोनों
sir.
square?
साइड
तो इसको
सर
ना
दोनों
हमने ना
साइड
दो
का
इंटरवल्स में डिवाइड कर देना है.
Ah, yes, yes, we can divide this one.
Minus
So
1
we,
less than equal to x less than equal to 0.
yes, yes, yes,
And
yes,
then 0 less than equal to x less than equal to 2.
yes, yes. But the question he was asking that when we have to take the reciprocal, when we have to take the reciprocal sign, in this case you will always take 1 less than equal to x square less than equal to 0. Here, yes, this is the case now. So here you can see 0 less than x square less than 1. Okay, it's all depends upon the condition. Okay, it's all depends upon the condition.
सर एक और केस होता है जिसमें अगर हम सिर्फ नेगेटिव नंबर से मल्टीप्लाई या डिवाइड करें तो साइन अपने आप ही चेंज हो जाता है.
Yes, yes, yes. That is the case. Let us suppose I have minus 1 less than equal to x less than equal to 3. Yes. So it will change. Yes. In this case, it is also changes. Okay. But in square, you have to just see whether which side is your less than there. Okay. Here I am taking the squaring. So 1 less than equal to x less than equal to 0. So 0 is always less than 1. So that's why I am changing the sign here. Okay.
सर अगर -2 लेस देन इक्वल्स टू x लेस देन इक्वल्स टू 2 हो तो
Minus 2 less than equal to x less than equal to 2. Same case, already Harkomal said we have to include 0 also here. 0 also. We have to include this 0. In this case, we have to take, we have to break the interval 0 less than x less than 2. Okay?
ओके सर. तो मतलब
Yes.
0 पहले आना चाहिए सर.
Yes, yes. Should I erase it now?
जी.
Okay. Now let's see the second part, second step. Yes. So I think Mansha is there in the class. Ashna, Mansha. Okay. So what is the second step?
सर फाइंडिंग वेट.
Finding P. So yes, Rohit, what will be H here?
Sir, H will be alpha upon n.
Alpha upon n. Good. Alpha upon n. So your first term is your 0. Then your value is alpha by n, then your value is 2 alpha by n, then your value is so on here. Yes, and last value is your n alpha upon n, that is equal to alpha, but you have to take point here, it is I alpha upon
Sir,
n. Yes.
sir, how this function is bounded? Because sir, alpha we can take alpha infinity also there in positive.
No, no, no. He says just only alpha is greater than 0. So we have to take one number because we are doing the definite integral. Just remember this thing. We are not doing the improper integral. Okay. We are
Okay.
dealing with the integration, that is a to b f of x dx. If I take a to infinity, so it will be improper integral. Okay.
Okay, sir.
Yes. Fine. Now, what is the next step? What is the P? Yes.
तो एक क्वेश्चन था सर, यहाँ पे अल्फा इज ग्रेटर देन 0, इसका मतलब यही हुआ ना कि अगर 0 से कम होता तो वो डिक्रीजिंग हो जाता,
फंक्शन
कि फंक्शन इंक्रीजिंग होना चाहिए, तभी तो
yes
अल्फा
yes
जो बाउंडेड है।
yes
यस, ओके,
yes surely, because f of x is x square, so you will always get the function as increasing.
यस।
Okay, now so if you compare with your point, so it is x naught, x1, x2 and xi minus 1 comma xi, okay, and xn equal to alpha, fine, and 0, okay. So what is xi here? Xi is your I alpha upon n, okay. Now find mi, small mi. What will be small mi? Yes, what is small mi, Nikhil Kumar? GLB, GLB,
अल्फा I माइनस 1 अपॉन n होल स्क्वायर।
1, yes, whole square. Means f of x, you have to write down in this way, because you are giving the exam, final exam, physically. So remember this thing, all this stuff must be written. So it will be I minus 1 or I something else. At which point you are finding the GLB? Yes,
Sir, f of
Arkomi.
x
X I
minus
minus 1. I minus 1.
But you have to write down here f of x is increasing. Okay, f of x is increasing. Okay, if f of x is increasing, then you can write down we are finding here GLB at your xi minus 1. Okay, so xi minus 1, so it is your I minus 1 alpha upon n whole square. So what is capital Mi?
Sir, XI.
Xi, yes, f of xi. Okay, so f of xi, so it will be I alpha upon n whole square. Now find LPF. Find the value of LPF. LPF. Mi delta I. Delta I is your alpha minus 0 upon n. Yes, calculate LPF. Yes, Rohit, have you calculated LPF?
no sir, doing sir.
Okay, okay, just do it.
Sir, 1 minute back कर दीजिए please.
I could not take this slide to back.
Okay, sir.
Which point you have not write down on your copy?
Sir, MI, small MI के second line.
Small mi is I minus alpha, I minus 1 into alpha upon n whole square. Okay, and your capital Mi is I alpha upon n whole square.
Okay, sir.
Yes. Now calculate LPF.
सर इसमें ना सीरीज बन रही है जैसे 0 1
Yes, yes.
0 plus 1 plus 4 plus 9 so on up to n minus 1 whole square.
No. Just remember 1 square plus 2 square plus 3 square up to n square. Okay. So it is your n into n plus 1 into 2n plus 1 by 6. Okay. So you have to apply this one. And if somewhere you find the formula 1 cube plus 2 cube plus 3 cube up to n cube, okay, that is your n into n plus 1
सर
by, yes.
सर ये लेकिन यहाँ पे 1 स्क्वायर प्लस 2 स्क्वायर सो on up to n स्क्वायर नहीं ना है यहाँ पे n minus 1 whole square.
So
सर
repeat,
n minus 1 by 2 हो जाएगा.
तो हम उसे
yes,
चेंज
yes,
कर
repeat.
सकते हैं ना n minus 1 into.
Yes, you can change it. You can change it. May change n to n minus 1. Okay. Yes, now Harkomal, what is the answer now? What about other students? Are they doing it or not? I equal to 1 to n. Okay. Mi delta I. Yes, Harkomal, what is your answer?
सर अल्फा स्क्वायर upon n square
Alpha
into
upon n square into
yes sir, into 2n minus 1 into n minus
2n
1 upon
minus
6.
into n minus 1
Yes sir, upon 6.
into upon
6.
6. Yes, what about other students? Have they got it?
सर मुझे तो अल्फा क्यूब अपॉन एन क्यूब आ रहा है मेरा.
सर अल्फा क्यूब अपॉन एन क्यूब आ रहा है सर.
Alpha cube. Okay, alpha, it must be
सर
alpha cube.
सिर्फ अल्फा क्यूब होगा नीचे वाला एक n कट जाएगा ना.
Take out n common. Yes. You can cancel out. You can cancel out this n also.
हाँ.
Okay. So I think so. Your answer will be alpha cube upon 6. Okay. Fine. Alpha cube upon 6. Take out n common also from here also. N square common. So it will be 2 minus 1 by n. 1 minus 1 by n. Okay. N square. This cancel out. This cancel out. This is LPF. Now find UPF. Find the value of UPF.
सर वो 2/n नहीं होगा. 2
Where?
by n प्लस 1 by n स्क्वायर. सर n स्क्वायर कॉमन लिया ना ऊपर से.
नहीं, यहाँ से n हो गया कॉमन और यहाँ से n कॉमन ले लिया, वो कंबाइन करके n स्क्वायर बना ना.
अच्छा
यहाँ से तो
सॉरी.
n ही कॉमन आया.
यस सर.
हाँ. Okay, what is UPF? Yes, what is the value of UPF?
Sir, it is alpha cube into
Hmm.
1 plus 1 by n into 2 plus 1 by n upon 6.
Okay, means you are saying 2n plus 1 here. 2n
Yes,
plus 1, n plus 1,
n plus
okay,
1 upon n square.
upon n. Yes, take out n common. So you will get alpha cube on 6, 2 plus 1 by n, 1 plus 1 by n. Okay. Now find the lower Riemann integral and upper Riemann integral.
सर सिमिलरली करके हम हमेशा यूपीएफ का जो रिजल्ट होता है वो एलपीएफ के रिजल्ट से उसका साइन बस चेंज हो जाता है ना हमेशा।
Yes, yes.
तो सर हमेशा
It
हम वो
will.
स्टेप नहीं मिस कर सकते क्या वो यूपीएफ वाला?
No, in the final exam, you have to discuss also. Okay.
सर
Similarly means what? Similarly means terms are same, but here it is sign are also changing.
यस सर।
Okay. If sign are also changing, then you have to show it. Okay. If there is means, let us suppose here it is x or here it is y, and the similar term is y and y, you can write down. But there is change of sign also. Okay. So that's why you have to show it. Okay. So what is the answer now? Yes, what is the answer now? Yes, what is the answer now? Komal?
Yes, sir, wait. 1 minute.
सर 2/3 अल्फा क्यूब बाय 3।
Alpha cube by 3. Good. So it is alpha cube by 3. What about other students? Only 2 or 3 students are studying, rest are just roaming in the market. Okay. This is the drawback of the online classes. Just you can move it here and there. Okay. Yes, answer is alpha cube by 3.
सर इसमें हमें वो दोनों का निकालने की जरूरत नहीं है ना यूपीएफ का भी आई मीन रिजल्ट से मतलब है ना।
रोहित, अगर इतना हो सकता है तो इतना क्यों नहीं कर रहा तू?
नो सर जैसे पिछले लास्ट क्वेश्चन में था कि शो दैट, तो हमें उसमें प्रूव भी करना था कि ये राइमन इंटीग्रल है। इसमें तो सर ये
हाँ.
वैल्यू होती है, तो इसमें
No,
हम
no,
एलपी
no, no. Question is about show that.
अच्छा अच्छा
Just
हाँ
check
सर
this
है।
thing. Yes.
या थैंक यू।
Hmm.
सर बड़ा ही लेंदी क्वेश्चन है सर।
Hmm. Sure. And you will get this question in the MCQ form. So see this, how quickly you have to do.
सर ऑफलाइन में कितने मार्क्स का होगा ये एग्जाम में?
10 marks.
10 marks.
Yes. Everyone got the answer?
सर एमएसटी में
Yes,
कितने
sir.
मार्क्स का होगा?
MST, same, I think so, 40 marks. There will be, I think so, 40 questions there. Okay.
सर ऑफलाइन केमिस्ट्री में,
Hmm? No, MST will be
ऑफलाइन वाली
online.
केमिस्ट्री में।
First MST online, second MST will be offline, and final exam will be offline. Okay.
सेकेंड केमिस्ट्री में
And
आएगा ही नहीं है।
क्यों? Okay.
यूनिट 2 आएगी ना सेकेंड केमिस्ट्री में तो।
Yes, there will be unit 2 also. In the unit 2, there will be power series and convergence also. Okay. So let's move to the next question now. Question is, if f of x is equal to 3x plus 1 in the interval 1 comma 2, show that it is Riemann integrable. Okay, Riemann integrable. Okay, so all these questions are quite lengthy one. It will take some time, but if you practice it, and you will solve this question by within 10 minutes or 15 minutes. So once again, interval is given 1 comma 2. You have to show it is bounded first of all. Since x belongs to 1 comma 2, okay, I will solve this question. 1 less than x less than equal to 2, and then multiply by 3. Okay, so this is the first step. Always you have to complete this step first of all. Okay, then you will show it is your bounded. Okay, after showing it is boundedness, then you can start doing the your second step, means divide into n equal subintervals. Okay, so it means that 4 comma 7. Okay, so you will say f of x is bounded function. Okay, bounded function. Now divide divide 1 comma 2 into n equal subintervals. Okay, n equal subintervals. Yes. Okay, so Harkomal, I am making you the presenter. Let's start doing the question side by side. I will ask the question from other students also. Okay, I am making you the presenter now. Okay, let's Harkomal.
Yes, sir.
What is the value of H here?
It is 1 by n.
It is 1 by n. Okay. Now divide this into the partitions.
So partitions are 1,
1. Next.
n plus 1 by n.
N plus 1 by n? No, no, no.
Because sir, 1 plus 1 by n, it is
Yes,
n plus
yes.
1 by n.
No, no. It is better to take 1 plus 1 by n.
Okay.
Yes. Next.
Then next is 1 plus 2 by n.
Good. Next.
Then 1 plus 3 by n.
Okay.
So on up to
And
1 plus n by n.
yes, it is 1 plus your n by n. Okay, so it is your 2. Fine. So in between, you have to take other values also. So it is your 1 plus I minus 1 by n. Fine.
Yes, sir.
And next,
1
1
plus
plus
I upon
I
n.
by n. Yes. Good. So everyone, I hope so. You understand this partition, how to do the partition. Just remember, h is your 1 by n. We have to take the partition in this form. Okay. 1 comma 1 plus 1 by n, 1 comma 1 plus 2 by n, comma 1 plus 3 by n, comma 1 plus I minus 1 by n, comma 1 plus I by n, and last in the, that is your 2. Okay.
सर एक चीज पूछनी थी सर.
Yes, yes.
सर हमेशा मतलब जो h निकला सर उसमें 1 प्लस करते जाना है.
No, no. It's all, yes, it's all depends for your initial value. If it is 0, let us suppose it is 0, means your initial value is your lower limit is 0. Then you have to write down 0, 0 plus 1 by n, next 0 plus 2 by n. It is better to write down in this way. Okay.
ओके सर.
So it all depends upon your lower limit. Okay. Any other doubt?
नो.
Okay. Should I read it now? Yes.
Yes, sir.
Okay, fine. Now, what will be xi here, Komal?
Sir, 1 plus I by n.
1 plus I by n. Now, find out mi, that is GLB, greatest lower bound.
So 3 into 1 plus I minus 1 upon n plus 1.
Okay, very good. Now you are doing very fast. So this question must be finished within 10 minutes. Okay. In the previous question, we have taken at least 25 minutes. So, uh, what is the value? Just repeat it.
So 3
Just
into
1 minute. 3 into
1 plus I minus
1 plus I minus
1 upon n,
n,
that
yes,
goes plus 1.
plus 1. Okay. So this can be written as 3I minus 1 upon n plus 4. Okay.
Yes, sir.
Now find mi, capital Mi, that is LUB. Okay. Least upper bound, f of x.
So 3I upon n plus 4.
Okay, but we forget one thing, very important thing. We are not write down because f of x
Is
is
increasing.
increasing. Yes. So remember this part. It is very important. F of x is increasing function.
सर अगर
Okay.
डिक्रीजिंग होता तो हम कुछ और लेते.
Yes, yes. We have to take this as, let us suppose it is your decreasing. Let us suppose your function is 1 by x. Okay. So if function is 1 by x, then you have to take mi as f of xi. Okay. At this
डिक्रीज.
point, you are getting the GLB because it is decreasing. Simple thing. Okay. So it's all depends for your function. Okay. Now xi. So here, since the function is increasing, so we are taking here this is your f of xi. So it will be your 3i upon n plus 4. Let's start finding LPF, lower Riemann sum. Lower Riemann sum. Yes, calculate the value. I am giving you 2 minutes. Calculate the value of LPF. What about other students? Are they doing it or not? Amanpreet Guraya, Amisha,
Yes,
Ankit
sir.
Singh
Doing.
Bhatia. Yes, you must
Yes,
do
sir.
it. Good, very good. So let's do find the lower Riemann sum. From B.Ed side, I am not getting any response. Rohan, Rohit,
Sir, doing.
Samriddhi.
We are doing.
Okay, very good. Thank you. Yes, find out the lower Riemann sum, LPF. Yes.
Sir, if we have series 3 plus 6 plus 9 plus on up to 3n,
Uh,
what
take out
is
3
the
common. Take out 3 common.
okay?
So it will be 1 plus 2 plus 3 up to n.
Minus 1, sir, up
Yes,
to.
yes. Yes. Have you calculated lower Riemann sum? That is
Yes, sir.
summation I equal to 1 to n. Okay, small mi, that is your GLB into delta I equal to 1 to n, 3i minus 1 upon n plus 4 into 1 by n. Yes, just provide me the result.
So see in the chat, sir, Muskan has written.
Okay, just 1 minute. I am seeing, okay. Muskan has written down that is 3 by 2, 1 minus 1 by n plus 4. Okay. So Muskan has given the result LPF, that is, just check the match your result. 3 by 2, 1 minus 1 by n plus 4. Okay. Harkomal, have you got this result for LPF?
यस सर सर मैंने लेकिन कटिंग कर दी मतलब कैंसलिंग कर दी
Okay.
पहले
Yes. So it is better to take n common. Fine.
यस
Okay. Now evaluate. Should I raise it now? Yes.
यस
Give
सर
me response on the screen. Okay, fine. So calculate the value of UPF, that is summation I equal to 1 to n mi delta I. Okay. So it will be I equal to 1 to n. So 3i upon n plus 4 into 1 by n. Okay. Yes. What is the result now? What is that now, Arkomal?
Sir, same result, sir. Change of plus sign. 3 by 2, 1
Okay.
plus 1 by
Sign
n.
will be changed. Yes,
Yes, sir.
Rohit, what is the answer? What is the answer?
Sir, 3 by 2, 1 plus 1 by n plus 4.
Yes, 3 by 2 plus 1 by n plus 4. So calculate the lower Riemann integral. Lower Riemann integral.
So 11 by 2.
Okay, very good. Lower Riemann integral will be 11 by 2.
Yes, sir. 11
Means
by
you
2.
will calculate here. Yes, very good. F of x dx. Okay, that is limit norm tends to 0. Okay, LPF. So it will be your limit as we are taking, just again I am again repeating, as we are getting p equal to 1 by n. When p tends to 0, obviously we will get here n tends to infinity here. Okay, so n tends to infinity, and 3 by 2, 1 minus 1 by n plus 4. Okay, so it will be your something on infinity is but 0. So it is your 3 by 2 plus 4. Okay. So in this way, this is 11 by 2. And similarly, we will get here upper Riemann integral. Okay. Upper Riemann integral. Okay. So it will be 1 to 2 f of x dx, that is your limit norm tends to 0. Okay, UPF. Fine. So it will be your limit n tend to infinity, 3 by 2, 1 plus 1 by n plus 4. Okay, so it is your 11 by 2. So I hope so you can do any question now for the Riemann integral. Okay, we will do some more question on Riemann integration, difficult question. Okay, that contains sin x and cos x. Okay, any doubt for Riemann integration you can ask now. Okay, very good. Okay, so simply if in the +2 class you can easily find the integral, the definite integral. Okay, but this Riemann integral, one question asked from Nikhil Kumar. Riemann integral is applicable to this a to b f of x dx, that is definite integral. If one of the limit is infinite, it not be possible to divide the interval into n equal subintervals. Okay. So with this, I am going to end this lecture now. I will meet in the next lecture on Monday. So thank you
Sir,
very much for attending the lecture. Yes, Rishabh, yes, Rohit.
सर ये बाउंडेड होगा तभी आगे इंटीग्रेशन बढ़ेगा ना?
Yes, yes, surely.
तो सर अगर इन्फिनिटी होगा तो कभी बाउंडेड हो ही नहीं सकता.
Yes, yes, बिल्कुल ठीक. Your idea is very correct.
यस सर, थैंक यू.
Okay.
यही था.
Okay. So thank you very much for attending the lecture now.